Hi, my name is Nino Brown. I'm with the University of Georgia. I'm an assistant research scientist within the Department of Crop and Soil Science, and I'm a peanut breeder. I work closely with Dr. Bill Branch, who's been the peanut breeder here for over 40 years now. Some of the things that we focus on is increasing yield, of course, increasing dollar value, improving disease resistance, as well as shelling quality, flavor, drought resistance, and just a lot of various agronomic traits that are important to growers. When I first got here, Dr. Branch and I started a trial to look at the genetic gain, so the progress that's been made over the course of the UGA peanut breeding program. To do that, we looked at all the Georgia runner varieties that have been released from the program, starting with Southeastern Runner 5615, which was released in 1947. And then most of Dr. Branch's runner varieties that he's released since coming here, starting with Georgia Runner, on up to Georgia 18RU, including, of course, Georgia 06G and Georgia 12Y. One of the things that we learned from that 3-year study was that peanut yields have increased over 3,500 pounds per acre since the inception of the peanut breeding program at UGA. And since Dr. Branch has been breeding peanuts in Georgia, yields have increased almost 2,000 pounds per acre. When we look at dollar values have increased by a little less than $650 per acre, and Dr. Branch has been responsible for over $350 per acre increase in dollar value. So just really underscoring the importance and the value of having a public peanut breeding program at the University of Georgia. So Dr. Branch has increased yields over 2,000 pounds per acre, and so it's important that we try to maintain that consistent rate of genetic gain that Dr. Branch has been able to achieve. So to do that, I've been looking at ways that we can increase our throughput within the breeding program. We have a lot of really interesting tools at our disposal as plant breeders today. We have a lot of high throughput phenotyping devices. So these are things like drones that can fly through the field and take really detailed measurements, high speed seed sorting machines, and we're using all of these technologies to try to apply them within the peanut breeding program so that we can maintain that high rate of genetic gain. We've had several years of using drones in our replicated yield trials. We're starting to use them for selection purposes in our nurseries. We're also developing a ground-based phenotyping robot called Watson with our collaborators in Athens, Charlie Lee and Ray Hsu. We're working with JLA to apply a high throughput seed sorting system to our breeding program to sort high oleic seeds from normal oleic seeds so that we can use those in our breeding nurseries to more effectively and sort the high oleic plants from the normal oleic plants in our nurseries. Several years ago, the peanut industry had the foresight to sequence the cultivated peanut genome, which has allowed us it's made it a lot easier to do things like genetic diversity studies so that we can understand the genetic relatedness of our peanut cultivars. And so we had a study a few years ago looking at all of the peanut varieties that have been released by the university over the course of its 90-year history to better understand how we can make crosses among related or unrelated lines so that we can maintain that constant rate of genetic gain to help improve growers' bottom line. So that's what I'm working on. We're trying to incorporate high throughput methods and new breeding technologies, new genetic technologies to maintain a high rate of genetic gain for growers in Georgia and beyond.